Okay, here's a picture of the region that we want to find the area for, bounded by the graph of x squared times e to the, I wrote it as minus 1/5 x instead of a negative 0.2x. And the fact that we got a product here and it doesn't look like substitution is going to work tells us that we might be wanting to use integration by parts to find the antiderivative for this. And here's how that happens. And I'll guide you through all of this, by pointing the directions that we're moving here. So if we're going to use integration by parts, probably want to let u equal x squared, and then dv will equal everything else. The antiderivative of e to the negative 1/5 x dx. Easy to take the derivative of x squared, 2x dx. Easy to find an antiderivative for e to the negative 1/5 x. Negative 5 e to the negative 1/5 x. And here's the formula we're using for integration by parts. U times v, that would be this term right here, minus the antiderivative of v du. Well, there's the v, there's the du. I can move the 2 times negative 5 out front, which is negative 10, minus a minus negative 10 becomes plus 10. And then we've got x e to the minus 1/5 x dx. Well, guess what? We got to use integration by parts again. So I'll take that over here. We'll simplify that expression and then substitute whatever we end up with, which happens to be right here, back in for what I circled in red. I won't take you through this. It's very similar to what we just did. U equals x, du equals dx, etc. And we reach the point where we're finding the antiderivative of this, which is just negative 5 e to the minus 1/5 x. So if I substitute this back in over here, distribute the 10, this is the antiderivative right here. I rewrote it up here and I factored a minus 5 e to the minus 1/5 x from every term, GCF. So there's your antiderivative. We want to evaluate that from 0 to 6. Put the limits back on here. And you could try to do this and leave an exact answer by just plugging 6 in for x and having something in terms of e. But here's a decimal approximation, 30.128. And if I go to board 3, there's the original function. There's the definite integral evaluated on Desmos, which matches the answer we got using that antiderivative. Okay, there you go. Hope that helped. Pause, take some notes if you need to. Integration by parts twice is what was required.